The stage is yours.
Thank you. Hello. Thank you very much for invitation. So recently I had a project in which we used design thinking approach. So I borrowed one idea. So please try to feel the persons you will see on the screen. So imagine you meet a John, who is a student, meet a Kate and Henry, they are freelancer or consultancy company, and meet the team. They have no names, they work in a big organization or they are inside in-house team. So John is using R mainly for homework or some hobby. Kate and Henry are making money out of R, delivering solutions to different customers, and the team is making value out of data for the company using a regular job every day. So meet those people because the stories that are behind them, I will use the stories to show you the reproducibility issues. So as we are in R conference, so all of them are coding in R and they are happy until one day. And this day is the moment when something went wrong, as you can see on this chart. And I'm sure anyone had this problem. So you wrote a great script and you shared it with someone else, and sadly it didn't work. And of course this is one of the problems you had on the slide, but there are many other different issues. So John failed with the homework because you remember professors. I hope there are some professors on listening to me. So the professors are very assertive persons and they don't accept installing packages on their laptops. So John had a problem to prove that he did the homework. So Kate and Henry were struggling to deliver a solution to the customer because they couldn't solve the installation of packages. By the way, do you know what is Red Hat Enteprise 6.8? How old is it? You see? Your parents knows. By the way, it's very stable. Enterprise loves this. Enterprise loves stability. And the team had a problem because the environment they have in the organization is being used by different users, and one user wants this package, the other wants the other package. The model they did half year ago used particular version of a package. Moreover, there is no internet access. Can you imagine working with R without install packages from CRAN? The team has to deal with that, okay? So those are examples, real examples from the real life that could happen to different people. So this is called reproducibility problem, and this is my view of the reproducibility problem. And so what's exactly reproducibility? So I define reproducibility in a functional way. So the reproducibility is the ability to run your code at least twice, probably in different time, so today and tomorrow, probably on different computer. So it could be my laptop, it could be yours laptop. By the way, my laptop is not forever. I mean, I drink coffee and sometimes it can spill off my laptop, so the laptop is changing in time. By the way, I install and remove software. So different computer can be the same machine, but changed state. And what is important in reproducibility is that the outputs of the program, given the same input, must be the same. So for example, if a program is not working and it worked 1 week ago, it's not the same output. So this is how I define reproducibility. Of course, the consequences of not having reproducible code is that, for example, you cannot repeat your computation from an article, scientific article, or you cannot deliver a solution to a customer. So there are different layers of reproducibility. So first is data, and this is solved. This is called data warehouse. So every time you do a software using data, you should build a data warehouse. Second is code. You should control if the code is deterministic. Next is solution dependencies. So, for example, what package version you use. Next is operating system. So you have to have on your production or development special versions of packages, additional tools, etc., etc. And the last is bare metal. It also can cause some reproducibility issues. So, for examples, this is a forecast package. This is a great package. I like very much. But this is very nice because the author gives you exact information what he changed. But what he changed in this last version is that he modified defaults. What's default? Default is that you don't give an argument to a function. So he modified, in fact, your program. The second is my favorite, data table. I will use this package, it's great. So this version was very famous in our company one day because unique changed from working on keys, so let's say 2 columns out of 100, to working on row, so on 100 columns. So your code was running. I mean, there were no errors, no API was still the same, but the function was completely different. And the last with bare metal. So we had a software, by the way, not in R, but in Julia, but running on development small machine chip. When we switched to larger, it didn't work. Why? This is something like half PCU here, and this is a full computer. So something is tricky on the cloud going on. So as you can see the examples. Oh yeah, and the rest, Dockerfile. I love this. So Dockerfile is famous for reproducibility. So this is unstable. So it means it's changed very fast. So today, if you make an image out of this Dockerfile, tomorrow it will be the completely different image. And what I like the most is run apt-get update as a first instruction in a Docker, which means adapt the image to the current time. So, by the way, they have a proper Dockerfile from the point of view of reproducibility. So, as you can see, there are 3 personas, different examples, and I try to find the real moments in programming R that reproducibility is important for you. So first is the moment that you share your solution to other person. So you make a development on whatever you choose, and you deliver to whatever you choose. This can be more tricky, it can be cloud or other versions. And the second is that you want to restore the development environment. So for example, you deliver the solution and there is a bug, and delivered the solution half year ago, and you want to correct the bug. So you have somehow on your on your laptop restore everything about your project. So in those 2 situations, you can see all the weaknesses of your workflow, of not from reproducibility point of view. Okay, but now I will switch to show you the solutions for the 3 personas that I believe help to manage reproducibility problem, at least maybe not 100%, but quite good. So about the John. So he does or either homework or some fun. In general, he's student, so he's concerned about fun. He's doing a development on a laptop. He can work with many projects, separated, so he can play for one homework. He's doing this version of package, for a master thesis the other version of packages. He's using Microsoft Run Time Machine for CRAN, so he can control versions of packages. And he's using version control. On this conference there was a lot about GitHub. It's easy. By the way, GitHub is not reproducibility safe, because you can change the history in the commits. For example, Subversion and SVN is safe. And what he does, he ships the solution as a zip file without no installation production. So professor has no way to accept the homework, because in a zip file you have the whole solution, every package prepared for the production. Next is a consultancy team. So this is the most complex. Why? Because the production can be anything, and you must be ready and do this fast. So you cannot say this only one production. For each production you have to prepare. You have a development working probably on a laptop, no server. What is important to add is a continuous integration tool. We are using Jenkins, but we had a nice talk about Travis. And we could deliver in a zip file, and we could use also Docker. I will tell a few words about this later. And the last is the team. The team has quite easy setup, because they have one production, one development, controlled version, Red Hat Enteprise, 20 years old. They use Jenkins for controlling and automating testing and deployment. They use version control. What they have to have is a local CRAN. By the way, the team should also have a local CRAN, because they have no access to internet. What is also different, they are working on one machine. Many people working on one machine, so you have to deal with the separated projects. Okay, so I would like to say one word about Docker, because I can read a lot of confusing blog posts. So Docker is not package management system. And Docker, there are two workflows we recommend. So one is when you develop a solution for a different operating system you use every day. So for example, we are using Windows, and you want to make a solution for Linux. It can be Ubuntu, it can be Red Hat or CentOS. This is almost the same. By the way, in Enterprise, Ubuntu is almost not present. And you use Docker for preparing what we call deployment package, which contains binary version of R packages with R scripts that you just unzip on production, and you can run this. So on production, there is no installation. Everything happens in a Docker container. The second is if the customer or the organization is ready to ship solutions using Docker images. So when you go from development, you produce Docker production image. This is completely different than Docker development. On production, you don't need RStudio. So it's not a good practice to have RStudio and treat this as a production version. And you can work on a Docker here and build a Docker image as a deployment package and send it to a customer, of course, with a version and everything. And as we are a consultancy company, we had problems with reproducibility when delivering our solutions, and created a tool called RSuite. This is open source, everyone can use it. And what you can see on the screen, it's part of functionality of the solution. So first, you have isolated projects, so you can have different projects on one laptop with different R versions. You can have binary packages, which is great for Linux. You don't need to compile anything. You can manage cron. It's compatible with Docker, Git, Jenkins, all the software engineer tools. There is no installation production. So experimental version of system requirements. You can put Python inside if you want to use deep learning. By the way, it's much better than any Python deployment system. And you can use this in internetless environments. So this is the tool that could be used in different workflows. As I also presented, there is no clear what is reproducibility for each person. Everyone has to find it themselves. And I would be glad if you could test this and give us a feedback. So thank you very much.
Excellent. Just on time. This is what session chairs like.
I did my best.
Thank you.
Deadlines.
Actually, now we have time for one question. I'm running.
Thank you very much. It was very
Thanks.
interesting. I appreciate everything, and with reproducibility from a scientist's point of view. And you have projects where you want to freeze everything and work with that for like a year or something. But I always get to that thing is like, when do you update? How do you update? I know you don't have an answer, but what's your thought about that?
Update what?
For instance, if you decide to freeze something and deliver that, and then later, a year later, you're missing all the bug fixes.
Okay, so to make an update easier, you have to divide the solution in layers. So as I told you, as I show, for example, if you use Docker, Docker is for managing operating system requirements. So if you want to upgrade operating system, your solution should be separated from this layer. Okay? So this is difficult to do this. You have to have a lot of tests as on the before speech. And if you are the solution is separated clearly, so you can answer which tool is for which problem to be solved, then you can do this quite less painfully. Okay. So testing and separating into layers.
Okay, thank you.
Thanks.
Thank you. It's like
Okay.
8